Welcome. In this video, we are going to take a look at problem 1 from chapter 9 of College Physics 2E by Openstax. Okay, we have two parts. The first part is we're going to be opening a door. We're going to push on it perpendicularly, and we know how much force and we know how much the distance is from the hinges. And we need to find the torque relative to the hinges. And then we need to answer, does it matter if you push at the same height as the hinges? All right, let's start with what we know. We know the force is 55.0 newtons. We know the distance, let's call it r. That is 0.850 meters. Okay, we know we're pushing perpendicularly. That makes theta 90 degrees. And we know we need to find torque. Okay, so for part A, what we have is, let's make our door look like this. Okay, we've got, and let's put, say this is the hinge side where the big dot is. So this will be our R vector. And let's just say we're pushing like this. So this is looking at the door from the top. So a bird's eye view. All right, we want to put these two vectors tail to tail so that we can see where the angle between them is. And so we will have our R vector like this, our force vector like that, and there's our theta at 90 degrees. All right, the equation for torque is R times F times the sine of theta, where theta is the angle between the vector R and the vector F. In this equation, the R and the F are magnitudes. All right, so the torque is going to be the 0.850 meters times the force, 55.0 newtons, times the sine of 90. Okay, this gives a torque of 46.75 Newton meters. Torque does not have its own unit. A Newton meter is an energy unit, but we're going to leave the units at Newton meters for torque because joules are reserved for energy. Okay, so to 3 sig figs, the 90 doesn't really count as a sig fig because it said perpendicularly, so I could have put 90.0 on that. So the torque is going to be 46.8 Newton meters. Okay, important to leave the units as Newton meters. Okay, now in part B, we need to answer, does it matter if you push at the same height as the hinges? The height of the push doesn't matter. Let's write that down. The height of the push doesn't matter. And that's because torque depends on force and the perpendicular distance at which the force is applied. Height is neither of those. So we can say torque depends on the force and the perpendicular distance at which the force is applied. All right, so I hope you found that helpful. Let me know if you have any questions or comments, or if there are any other problems you'd like to see me solve. Your feedback is important and it will help me to make better content for you. Thank you for watching. Please like and subscribe, and I'll see you in the next one.